Good morning, students. Today we are going to see a very interesting problem on projection of planes inclined to HP as well as VP. So we will be seeing the problem statement. A pentagonal lamina of side 35 mm is resting upon its edge on HP so that the surface is inclined at 45 degrees to HP. The line joining the midpoint of the resting edge to the opposite corner is inclined at 30 degrees to VP such that the resting edge is away from VP. Draw the projections of the lamina. So I will be showing you the lamina. So this is the pentagonal lamina, and I have named the points as A, B, C, D, E. So the resting edge will be AB, the midpoint of the resting edge is F, and the opposite corner is D. I am connecting the points F, D. So this line is inclined to VP at an angle of 30 degrees. So the whole lamina is making an angle of 45 degrees. So if you consider this as vertical plane, this is how the lamina is. So this is my HP, this is my VP. So the lamina is tilted so that it makes an angle of 45 degrees with HP. That is, the surface is inclined to HP at an angle of 45 degrees. Then this is my stage 2. Then I will be tilting the lamina so that this line FD is inclined to VP at an angle of 30 degrees. So this is my problem statement. So we know that whenever the surface is inclined to HP, we will make the surface on HP. So this will be my stage 1. So I will be keeping the lamina on HP. Then I will be drawing the top view first. I can see the pentagon. Then I will be drawing the front view, which will be a line. Then second stage, I will be tilting so that the lamina is inclined at an angle of 45 degrees. So the front view will be again a line. The top view will be a reduced pentagon. Then stage, I will be tilting so that the line FD is inclined to VP at an angle of 30 degrees. It is a very interesting problem. I will be using a software which is called as OpenBoard, and let me go to the software directly. I hope the problem statement is clear to you. Now I will be drawing an XY line. So this is my XY line. Let me use a scale and let me draw the XY line. So this is my XY line. Let me name these points also. So this is X and this is Y. Now I will be drawing the top view where I can see the pentagon. Let me choose blue color, and this is the pentagon. So this pentagon is resting on HP. Let me name the points also of the pentagon. So this will be my point A. Let me call this as point A. This will be my point B, C, D, E, and this midpoint is F. So I will call this as F, and midpoint. Here again I can join the line connecting the midpoint to the opposite corner. So this is the line FD. So I am having more interest towards the line FD because the line FD has to make an angle of 30 degrees to VP. Now this is my top view. Let me draw the front view. So let me draw the projectors. So here I am drawing my projectors. Then let me draw the front view. So this will be my front view. So let me give the names for the points. So this point will be, if I look from here, I can see B dash, whereas A dash, F dash will be in bracket. Let me not write it here. Likewise, C will be seen here. So this will be C dash and this will be D dash. Now I am tilting so that the lamina is making an angle of 45 degrees to HP. So this is my stage 1. In my stage 2, I am tilting my front view at an angle of 45 degrees. So I am taking the same length here and the length is inclined at an angle of 45 degrees. Now this is my new front view. Let me also name these points. So let me call this as B dash, C dash and D dash. Now I can draw the top view. So by this tilting, we know that the points will be having same distance with respect to VP. So now I will be drawing the projectors and I will be getting the distances from the previous top view, and this will be my new top view. From the previous front view, let me again draw the projectors. Now let me name the points. So let me call this point intersecting point. So this will be my B dash, this is my B. So this is my B, the new top view. So this will be my point A, B. Here I have point C, here I have point D, here I have point E. So this will be my point F. So instead of F, let me call this as F1 because the length is reduced. Let me call this as F1. Now let me connect all the points, thereby I will be getting the top view of the pentagon while it is tilted at an angle of 45 degrees to HP. So I hope that the lines are visible to you. So this is my new pentagon now, A, B, C, D, E, and this is my front view, this is my top view. So with this stage 2 is completed, now we will move on to stage 3. So in stage 3, I will be tilting so that the line DF is inclined to VP at an angle of 30 degrees. This is my third stage. So during this process, what happens is my height of all the points will remain the same and the shape of the top view will remain the same compared to the previous view. The important point here is this line FD, which is in true length in stage 1, by this tilting it has length is reduced in the top view. So when the length is reduced, what we are getting here is only apparent length. So we cannot tilt the apparent length to the true angle. So the concept is we have to find out the apparent angle. Let us follow this process to find out the apparent angle. So what I do is, in stage 3, I will be drawing a line at an angle of 30 degrees. So this will be my true angle 30 degrees. So I have drawn this for an angle of 30 degrees. This is true angle. So this will be my point, say D, point D here, and this will be my point let me call this as f. So this df is the true length. So I have taken this length of df from the first stage. So I have drawn an angle at an angle of 30 degrees. Then I have measured at any arbitrary point d. I have taken this length of df from stage 1. I have marked it on this inclined line. So I got this point df in the third stage. Now what I will be doing is, I will be drawing a horizontal line through the point f. So this is the line which is also called as locus of the point f1. Then what I do is, I know the apparent length. From stage 2, I take this length df1. You can use a compass, take this length of df1, that you can mark it. So draw a arc for a radius equal to df1. Take this d point as center. So you can get an arc, and this will be the point, and you can connect it like this. So this will be my point f1. I repeat again. I have drawn an inclined line at 30 degrees, that is true angle. I have taken a true length on this line, that is df. From f I have drawn a horizontal line. Then in stage 2 I have measured this df1, that distance as radius, this point d as center. I have drawn an arc to cut this horizontal line drawn through f, and you will be getting the point f1. So you have to join d f1, that is now the new top view line. Now if I align this top view so that this df1 coincides with df1, I will be getting the third stage top view. So to do this, what I do is, I have this line df1. Now I will be drawing the point AB. So what I do is, to the line df1, I can draw a perpendicular line. So this angle is 90 degrees. So this also will be angle of 90 degrees. Then you measure this length AF1. So from F1 you measure, you will be getting the point A here. So this will be my point A. So from the stage 2, measure this F1B. So from here you fix it, you will be getting the point B. To get the point C, what you do is, I know this length BC, take this B as center, this BC as radius, you draw an arc. Likewise, I have the point D here, DC as radius. From the stage 2, this point D as center, you can draw an arc. So these two arcs will be intersecting, I will be getting the point C. Likewise, you will be getting the point E also. So now I got all the 5 points. Let me connect all these 5 points with the help of a line. So I got AB. So I join BC, I join CD, and I join DE, and I join E. So this is my pentagon in third stage, while the line is inclined to VP at an angle of 30 degrees. So once you got this top view, then I can draw projectors. So I can draw vertical lines through all this. So I will be getting vertical lines through all these points. Let me also mark this point F. This will be point D. This will be point C. This will be point B. Okay. Now I got all the 5 points. Let me join all the 5 points. So this is my A. B here. C here. D here. E here. let me name the points for your convenience. So let me use a pencil. So this will be A dash, B dash, this will be C dash, D dash, E dash, and this will be the point F dash. Let me call this as F dash or F1 dash. Now let me draw this line DF. So using a red color line, so which is my interest. So this is DF1. So let me call this also as DF1 in the top view. Now the projection is over, the main problem is completed. Now we have to verify whether DF is making a true angle of 30 degrees. Now let us consider this as a projection of line. Our interest is only DF. So this is D dash F1 dash, which will be the front view. This DF is the top view. Now let me find out the true length of DF, as well as let me find out what the line makes with respect to VP. So what I do is, I will make the line parallel to HP. Now what I do is, I will be going to applications and I will be taking a compass. So we have used the compass. So with F1 dash as center, F1 dash D dash as radius, let us draw an arc so that this line F1D will be made horizontal. So I will be doing this process now. So you can see the line which is made now horizontal. So let me call this point as D2 dash. This point is D2 dash. Now from D, let me draw a horizontal line. From this D2 dash, let me draw a vertical line. The intersecting point, let me call this as D2. Now if I join this D2 with F1, I will be getting true length. Let me use a different color. Let me use a green color. So this will be my true length now. And now I have to see that this D2 F1 is making an angle of 30 degrees. And this is the way by which we are getting the true angle, that is 5. So now let me find out. Let me use the protractor from the software. We got the protractor now. Let me keep it on this point D2. Very good. Now let me turn this protractor. Now let us see that what angle this line makes. We can see very clearly D2 F1 is making an angle of 30 degrees. So this is the true angle the line D F1 is making with respect to VP. And to cross check whether this F1 D2 is true length or not, let me again use a scale. Let me take a scale. So I can move the scale. Let me measure the true length of FD. It's around 75 mm. Let me find out this length of F1D also. I hope that this also will be making a length of and this is F1, and let us see this length of F1D2. This is also around 75 mm. So that means I got this true length as well as true angle by using the projection of lines concept. So now we have understood the projection of planes as well as the projection of the lines concept very clearly. So when we have to use this kind of process is whenever in stage 2 you are not able to see the true length, you are having only apparent length, but what is given in the problem is true angle, then we have to find out this apparent angle using the procedure what it is told to you. Now if you see that this will be the true angle 30 degrees, and we have taken this apparent length and we have marked a arc here and we got this point F1 here. So this is the process by which we will be drawing the projection of planes whenever we don't have the true length in the second stage. I hope the problem is clear to you. Let me show you the answer which is drawn manually. So this will be giving a complete clarity for you. So this is the pentagon in the top view, stage 1, and this is stage 1, and this is the front view. I am tilting to 45 degrees. This is my stage 2 front view. This is my top view, and this is my stage 3. So I have drawn the line at true angle of 30 degrees. I have taken this true length here and I have marked this true length here, and from here I have drawn a horizontal line. Then I have taken this apparent length, I have taken this length as radius, this point as center, I have drawn an arc to cut the horizontal line. Now I got this point here F1. So I have joined this one. So with that I have completed the top view. I have just changed the position of this top view to this position now. So once I have this top view, I have drawn the front view. So now I have completed the projection of planes using the main drawing sheet. So I hope it's clear to you. So we understood the projection of lines as well as projection of planes using this problem. Thank you.